Hello everybody and welcome to the 8th installment in the Aorb Tech NumPy course. Today we're going to be talking about trigonometry. In today's episode we're going to be covering some helpful functions, trigonometric functions, and inverse functions. And as always we'll start by importing NumPy, so let's just do that. And of course run that block of code. First of all, we're going to be looking at the helpful functions, and these functions really are helpful because especially for some of them, we're going to be using them throughout the rest of this episode, especially when dealing with trigonometric functions and inverse functions, so basically everything. Starting with the deg2rad function. This function is very useful, probably the most useful function in this episode. Essentially what it does is it converts from the unit known as degrees to the unit known as radians. Now, degrees, most of you will know, are a way of representing angles like 90 degrees, 180 degrees, 360 degrees, and so on. Radians are simply another way of representing angles using a special kind of unit. They are based in the pi constant and they're used widely across mathematics. And they are also used in our trigonometric functions, which is why we're going to need this function for this episode. So to see what this function does, let's really quickly put down a block of code. We can use the numpy.deg2rad function, and we'll put in 90 degrees, and if we print this, we can see what the radian equivalent of 90 degrees looks like. Let's run that, and as you can see, we get 1.57 and so on, a bunch of numbers basically. Rad to deg essentially does the exact opposite, so just to test out if this works, because we could put in any number and it would still be kind of confusing, let's try and do the inverse of this number over here and see if it gets kind of close to 90 degrees. What we can do is we can literally copy this number over here. Then we can use the numpy.rad2deg function and we can input our number in there and see if it's like kind of close to 90 degrees. So let's print that out. Oh yeah, we actually get exactly 90 degrees. So yeah, there you go. And finally, we're going to be looking at pi, and this one's kind of self-explanatory. It just returns the pi constant, which not only is a very extremely important number in mathematics, but is even more useful in trigonometry. So let's really quickly print out our numpy.pi, and then we'll just kind of print that out, and you can see we have the constant here. I mean, it's not the full constant, but you have about as accurate as you can represent it for most purposes. Let's move on to trigonometric functions. Now, these are nothing special. They're about the same as those you'd find on your scientific calculator. If you've ever used one in uni or high school, you know what I'm talking about. And basically, they're just a way of taking an angle and kind of giving you a number that represents it as a sort of ratio. Again, they work in degrees. So we're going to be using our degree to radian function that we discussed earlier to help us use these functions. To test this out, let's start by creating an array. We're going to call it degrees. We're going to use the arrange function. And we're going to visit every 15 degrees from 0 to 180. And so we're going to use a step by 15, or step size of 15. Visit every 15 degrees, and let's print it out just to see what we're looking at. There we go. And now let's create another array called radians. And it's going to be essentially a conversion from degrees to radians. So that means we're going to need to go up and use the degree to radian function from earlier. So numpy.deg2rad. Then we're going to input our degrees array. Now let's print that just so we can see what it looks like. It's going to be a bunch of crazy numbers. It doesn't make too much sense. Although as you can see, we have pi at the very end, 3.1415, etc. And this is because radians are essentially stored using pi. In fact, the exact ratio is pi divided by 180. So if you use 180, if you multiply by that, you'll get pi. Now we're just going to go through each of these trigonometric functions one by one, starting with sine. So for sine, we need to use numpy dot sine. And what we want to do is we want to visit every single one of these that we have in our radians array. So we're going to do a for loop. We're going to create a new variable called radian. And we're going to access them from the radians array. And we're going to print the result of using the sine function, the numpy.sine function on the radian. So let's go through that one more time in case it's a little confusing. What we're doing is we're creating a for loop. This is going to access each of these elements in this array one by one, so each of these values here, and it's going to run them through the sine function. And then we're going to print that result to see what it looks like. Now, if you remember anything from your trigonometry class, this sine function starts from 0, it kind of goes up like a wave, and then it goes back down once it reaches 180 degrees. So if we print it, we should expect values starting from 0, going up to 1, and then slowly going back down to 0. So let's see what it looks like. And as you can see, we get a number 0, slowly goes up to 1, and then it goes all the way down basically to 0, although I think there's been some kind of floating point error here, because we've got a number that's very extremely close to 0, but not quite. So that's just a limitation with computers in general. But next we're going to be doing the cosine function. So let's just copy this for loop here. In fact, let's copy this entire code block here. We're basically going to do the exact same thing, except we're going to use the NumPy cosine function. And basically this is going to do exactly the same thing. It's going to apply each of these values inside of the cosine function. So now we're going to see what values we get. Now, if you remember from trigonometry, again, the cosine starts at the top, so it starts at 1, then it goes down to 0, somewhere around 90 degrees, and then it reaches sort of its lowest point at 180 degrees, so somewhere around -1. Let's see if that's what we get here. As you can see, we started from 1, we end up somewhere around or very close to 0 near the middle, and then we at the end approach -1 or reach -1. Finally, let's apply this to the tan function. So let's just change this function here to tan. And again, this does the same thing as we've been doing for the other two functions. It applies all of these radian values that we converted from our degrees. So these degrees here, because again, these functions use radians instead of degrees. And then we get the values. So the tan function kind of goes like in a you can imagine it as going all the way from -infinity up, creating a sort of saddle, and then going up to +infinity. So the values we get here should be can be a little bit strange, but we'll see what it looks like, and hopefully it checks out. And at 0, 0, we have a sort of gentle slope going up, becomes an extreme slope going up. So we start at 0, slowly increasing our values until we reach ever so closer to infinity, and then we start from the negatives. So we start going up, approaching 0, and then going up again from the left to the right. And as you can see, that's somewhat what we get. We could make this more accurate by using a smaller amount of degrees, a smaller spacing between each of the degrees. Instead of every 15 degrees, we could check every 5 degrees, for example. But just for the case of this demonstration, we're going to be looking at every 15 degrees. And as you can see, this works perfectly fine. But remember to always convert from degrees to radians first before applying them to this function. Finally, we're going to be looking at the inverse functions. The inverse functions literally do the exact opposite as the trigonometric functions we looked at earlier. So the sine, the cosine, and the tan functions. These are represented by arcsin, arccos, and arctan. Essentially, what these do is they take one of these numbers, for example, and they convert them back into degrees, or in this case, radians. So let's start off with arcsin. So let's create a block of code here, and we're going to print the result. What we're going to do is, first of all, we're going to use NumPy, and then we're going to convert the radians that this function gives us to degrees, just so it makes it a little bit easier for us to tell what we're talking about. So now we're going to use the numpy.arcsin function, and if we go up here, remember that for sine, 90 degrees, which was somewhere in the middle here, there it is equal to 1. So if we input 1, we should get the opposite, and then we should get 90 degrees as we're converting the radians that this function gives us into degrees. And as you see, we get 90. Now, if we don't use this function here, rad2deg, it'll just give us the same value that we would have gotten over here, if we can look at it. This value somewhere in the middle here, which represents 90 degrees in radians. It's, I think, somewhere, one of these values here, 2.35 or 2.09. So if we print it, we'll see what we get. 1.57. Okay, so we were a little bit off. 1.57, that's this value here. So this value represents 90 degrees in radians. So the reason we used that function earlier, if we put it back, is we're converting from this number back to degrees. So let's do that one last time. As you can see, we get 90 degrees. We can do the same thing with arccos. So let's print. Let's put in our NumPy dot arccos, and then we'll convert it into degrees afterwards. So let's just see what number we get. So if we put in 0, let's see what number we get this time. Let's try 0. We get 1.57. That should be 90 degrees, because remember, the cosine function, it starts at 90 degrees. So now let's use the NumPy dot rad2deg, so radians to degrees, and we should get 90 degrees, hopefully. 1.57, as we can remember from the previous example, gave us 90, so hopefully that's what we get. And there we go, we get 90 degrees. Perfect. Let's try something like 1. Now, this should represent 90 degrees. What we should get is 0, because cosine goes down to 0 by 90 degrees, and it starts going below the flat line, or the y position of 0 once it reaches that point. So we should get 0. There we go. And let's move on to arctan. So again, very similar thing. What we're going to do is we're going to print. Let's do NumPy, and let's just directly convert it to degrees. So rad2deg. And then let's put in the NumPy dot arctan function. And let's put in 90 degrees, see what we get. 45. Let's put in a number like 0, see what we get. It should be 0. There we go. Let's put in something like 270. See what we get. We get 89 degrees. So you can play around with these. You can use these for your code if you want to use something in your project that has trigonometric functions. The inverse functions are useful as well. And of course, you have the pi constant, the degrees to radians and backwards conversions. And I think they're quite useful. And that's it for this episode. It was quite a simple episode, just some functions that basically convert from one value or one unit to another value or unit, but still quite useful, especially in the field of mathematics and data science. If you enjoyed this episode, make sure you like, subscribe, share it with someone if you want to share the gift of coding and programming and learning something new. Make sure to hit that bell icon if you want to see more episodes like this. All of the source code from this project and from this episode is available in the GitHub, in the link in the description, or the link available here to access our website if you'd like as well, which will also be in the description. You can access this series and many more on our YouTube channel. If you have no idea what we're doing here and you feel like you're a bit out of the zone or you want to revise your programming skills, we also have a Python course available for you to check out. So make sure you check that out, or maybe send it to one of your friends. Have a lovely day, and I'll see you hopefully in the next episode. Bye-bye.